Hey everyone, welcome back to another live stream. I love doing live streams because it's more interactive. This is a very special one because I'm here with my good conference friend Nelly.
Hi.
Um, how's it going?
Good, good, all good here.
Nice. So Nelly and I, we collaborated before, and we have been cross path across so many conferences. Um, so yeah, I believe we can get started. The session format is the usual. We'll do some nice demos, answer some of the nice questions. In today's topic, we're talking about application observability. We're going to introduce a new tool called Autometrics and yeah, answer some of the nice questions around metrics and cost efficiency and observability for your applications. You can see we're close to 100 people already, so I'm sure we'll get more. So, folks, please share in your questions. It's being live streamed on YouTube and LinkedIn, both. It's being recorded as well, so if you're missing out, don't worry, you can watch it later on. I'll leave the links in the description below for you to check out as well. Um, yeah, so feel free to share your questions. We'll answer those in the end. And Nelly, take it away. Maybe you can give yourself a quick intro.
Yeah, I do. Thanks for inviting me, and everyone watching, thanks for joining. So today I'm going to talk about application observability with Autometrics and Beyond. And actually, it's exciting for me because yesterday we had a bigger launch at my company called Fiberplane around Autometrics 1.0. I will obviously explain later what Autometrics is and why do I think we need to talk about application observability. Well, I think if we look into more complex scenarios that we nowadays have with cloud native technology, but also microservices, the service itself might get less complex, but what we do have is a more complex communication pattern. So when we talk about observability, it's not only the application we need to consider, we also need to consider the communications to observe the communications. And obviously, beside the communications, we also have a more complex infrastructure that helps us with scaling down and scaling up if needed. So if you are on Kubernetes or any other similar cloud or orchestrator, it might look something like this, that your services live in containers, and the containers, you deploy them to a pod on a worker in Kubernetes, and that might also include some sidecars on the side. And that all of this, when we talk about observability, is something that we want to consider. And today I'm focusing on this particular service because I think there is some interest here how we can make sure in the development phase that our service is in a good shape, also for like the performance, but also that things that can help us with debugging. And yeah, I was already introduced. Who am I? I'm Nele. I work for Fiberplane. I joined almost a year ago, last January in 2023. And before I worked for a company coming more from a backend engineering perspective and worked more with backend engineers. And now there is a switch. And I think observability is quite an interesting topic because it's not one of those things that is meant to be the topic of one team. From my perspective, if we really want to observe all the different components that I just showed you, everyone in every engineering team needs to be on board when defining an observability strategy. And I hope kind of the session will outline in the end why we need to get everyone on board. And yeah, I know now you know who am I, but I don't know who you are. And I've created a small Mentimeter. So it also contains, the first thing is a quiz question because I'm pre-lunch. So I'm in Berlin, and after this webinar, I'm going to have food. So don't wonder, the first question is a food question. So if you join this Mentimeter quickly, that would be cool. Let's see what's happening. I don't know if I need to refresh this. I'm waiting for people to join.
Show the QR code again. Yeah.
There's the QR code. Well, if no one joins, that's also fine. If people are just enjoying watching, I'm fine with that too. But I'll leave it for a while. So unfortunately, there's nothing to win. I think if there would be something to win, people would jump on it straight away. But I don't have anything to give away. So I'm sorry. But yeah. let's see if there was we have one person. That's nice.
Just give me a second. I have shared the code in
Okay.
the chat. So you can just go to the chat and folks can join from there, hopefully. All right, I think we can get started.
Yeah, we can get started. Don't worry. So, well, there's one question, only one question to wake everyone up, and there is no result yet. Oh no, wait. The question should be here. Oh yeah, there is the question. And Kunal, if not, you have to answer it. Like, I found it interesting that chicken tikka masala is popular as an Indian dish in the UK, but where was it actually invented? You might know this, but I don't know. And we don't have anyone playing. Do you know? Or do you have any guess?
Mumbai, India.
No, it was not. It's interesting. Oh, well, I mean, I guess the chicken tikka, it comes definitely from India, but there is some, or at least if you Google it, there is some history around it that it was probably invented in Glasgow from a Bengali chef who needed to put some sauce on top of it, or needed to invent something, and then he had the sauce and he put it on the chicken tikka, and that's how chicken tikka masala was born. So yeah, I found this fact quite interesting. Well, so there were some people playing. Okay, no one got a point. Sorry, but yeah, maybe. Well, now we know. We already see what is your current role. I have one here in the DevOps space, SRE. That's cool. There are others. Yeah, it's hard nowadays to really say which are your roles. Sometimes the job titles also are quite confusing. But as I said, also I want to understand a little bit the audience. That's nice. So there's a good mix. Oh no, we don't have front-end engineers here. That's interesting as well. But yeah, also good. There is no good at bad. And then also the experience with observability. Oh, there are already some experts. Okay, that's good. Cool. And also someone was known. So I try to keep it as an introduction so everyone hopefully can follow. But also, if you are more advanced already, I hope you can still take something away here. And that is an open question. And I think I leave that for a while. And wait what you respond, because what do you hope to learn today for your role, or maybe from this webinar? Maybe a good reflection. Why did you show up and join the session for 45 minutes? Is it just because you like to see Kunal and me talking, or is there anything? Okay, I hear already function level metrics. That's quite exciting. Yeah, that's something we build at the moment. But yeah, I leave this open and I start the presentation because also due to the time. I mentioned already the application observability. Yeah, so when I talk about observability, I mean basically that we need to get telemetry data out of our applications. And it's not only about metrics, but normally we have logs, metrics, and traces. And the interesting part really is that we can find the same information in all types of those data, but we need to combine them to really make sense out of them. So I give you an example. So if you look at a log, for example, in a log, it's okay to find out the duration, how long a certain call has taken. So the log normally tells you here in nanoseconds that specific call has taken whatever time is there, like I even can't say this number, but you get the idea, right? So there is the idea to get the time, how long something was in execution. But this time alone really doesn't give you any indication if that is a good value or bad value. So it doesn't really tell you, is that compared to other things in my system something that runs very long, or that's something that runs really quickly and short. What you really need to understand is actually metrics. And metrics over time accumulate those values. And so you get a good insight into your system over time of the behavior of your system. And based on that, you can basically understand now, is that certain call one of those that took longer, or is it one of those that went quicker? And that's already good information. And there can be various reasons, obviously, why that is the case. Could be also that the request load is more or whatever. But sometimes if you go then deeper and you want to debug your system, and we just talked about the complexity of cloud native infrastructures, but also like the microservices, what you then also need afterwards is basically the trace. And the trace is the causality in your system. So you can create a span over a certain call, and that like would translate to like a whole call chain, and you could see how the causality of a specific call is, and then also understand maybe if a certain endpoint is called, that always takes long, and then based on that you can start your journey to understand why that is the case. So basically we normally need all three telemetry data types. And if we look into the components that we have here, talking about applications specifically, is that we have our application here on the left-hand side, and we need to instrument those functions, or sorry, not functions, but we need to instrument the code to get telemetry data out. So basically we need to identify ways to extract those data from our application, and then we store them somewhere. So somewhere is normally our observability data backend. And I come to this in a second, but we store traces, metrics, and logs there. And then based on that, or based on this data backend, we often, or we should have something like a query, alerting, and visualization platform, because a trace on its own or a span from a trace on its own is nice, but it's also not super easy to digest. So you need a form where you can basically see the thing in a visualization, but also like maybe the metrics, you want a nice graph, and you don't want to have the pure number, because that is maybe not the most useful thing. And actually it's getting a little bit messy in this field, or not messy, but there's a lot of different tools you can choose from. And there are obviously some vendors that provide a full-fledged vendor solution here. So where you can store metrics, logs, and traces at once. And you have one query and alerting and visualization platform basically on that. Normally you pay for those tools, but I think it's also worth looking at the open source tools that exist, and maybe decide if you start with observability to see if open source tools can help you. And on that end, I just named here a few. For logs, we have obviously from Elastic the LStack with Logstash and Grafana Loki. We have metrics. Clearly leading is Prometheus. I've never used Graphite. So if you ever use Graphite, please leave a comment in the chat. I like to talk to you. I like to know how that goes. And on the traces side, we have Zipkin and Jaeger. And then we have unified visualization. We have Grafana dashboards, we have Kibana, but also like I put here Fiberplane, because also Fiberplane doesn't store data, but the notebooks in the end is a way to get data in those notebooks. So there are various tools. They differ from each other in certain ways, but yeah, so it cannot be, or sometimes can be hard to choose which one to take. And if I go back, the interesting part here with the different tools is that few years ago, each tool provided a own library to instrument your applications. So basically all the vendors, like closed source vendors, but also open source tools, they had their own instrumentation library and told people use this and you can get the telemetry data into my tool. And well, basically then you have them and you can analyze them. And in the recent years, this has changed, luckily. Because there is a new project from the CNCF called OpenTelemetry, and OpenTelemetry really sits here on the part of the instrumentation of our applications. So what it does is it provides a vendor neutral way to instrument applications. You have manual SDKs or manual agents where you manual SDKs where you can go into the code, and you have auto instrumentation. That's an agent that runs next to your applications for different languages. So it supports almost every coding languages, I think. And then it also includes protocols and specifications, how telemetry data should look like. And that is very handy because all the vendors and all the open source tools are contributing to the standard, but are also I missed that word, but are also kind of agreeing that they want to support it, basically. So all the all the data backends can handle OpenTelemetry data nowadays. And then there are also some components, like for example the OTel collector, that's more like a proxy thing where you can send the data to, and from the collector send it to the data backends if needed. So you have kind of a proxy in the middle. That makes especially sense if you run microservices, if you have multiple services where data comes from, not to push it directly to the backends, but then maybe have the collector as a proxy in the middle. Maybe you need to do some data transformation in there as well. So that's all handled in the collector. And I outlined that already briefly. It's from the CNCF project. It's vendor neutral, and it was merging open tracing and open census in the beginning. So it has a history with tracing. And if you look at the status of the single implementations, tracing is the most full one, and they do now metrics, and also logs is on the horizon, but logs is more in an experimental status still. But if you look for tracing standards, OpenTelemetry really made the way out there. And it doesn't provide the telemetry data backend, so you still need to choose one of those vendors where you want to store them, or an open source tool. And I mean, theoretically now you can switch out the components quite quickly. I say theoretically because obviously I can change this one here, the observability data backend, if everyone supports OpenTelemetry data. But where I still might have a problem is when I want to migrate is the query alerting and visualization. So that is normally a different topic, different languages that I need to use here. So it makes the migration easier, but there is still work to do. So it's not like switching like this, your vendors, but it really eases the process. If we look into the instrumentation part, I briefly outlined it. We have the auto and we have the manual approach. And the auto approach is basically you don't have to touch your code base. You can install the agent next to it and get some stuff out. And manual would be you need to touch it or not need to touch the code base, but you can really fine tune it. And I just like to outline quickly how auto instrumentation looks like, and that's not even Autometrics, but just gives us some context what we can get from auto instrumentation. I even don't need to open the code because it will not touch the code. I can basically, it's a Python application. It's a to-do backend, so it is not even something super exciting. The link will be shared later because I will be working in this app for the presentation. But I can pip install the OpenTelemetry distro. And I did that already, but yeah, if you haven't, it would outline, or it would download basically SDKs and APIs from the OpenTelemetry things, and then I have OpenTelemetry Bootstrap, and that's interesting because now I have an app, and this basically gives me information of all the parts I can auto instrument with the Python agent. So I see already there is some stuff in here, and I also see that's the fast API app. And basically, if I do the Bootstrap minus all install, I say basically give me everything, and all the packages are now installing here. And I think I've saved this command somewhere. And let's remove the app name for a while because I want to outline the manual instrumentation on that app name. But what I can do is I can use the OpenTelemetry instrument, and I can define the log exporter to the OTel standard. And if I don't define the endpoint, I can even like print the stuff into my terminal. Not super exciting because that would be like numbers and the trace in a JSON format. But if I don't define it, it will put them or it will push and export them automatically to an endpoint 4317. And I have a Jaeger running there just to outline some traces. So my app is starting. I also can now I have a script here for this app, so I can basically also start some traffic here. So now this app is getting traffic, and if I go now to my Jaeger that is running also locally, what I can do here now is that was the one that has no name at the moment. We use a name tag later for the manual instrumentation approach, but I can say, okay, find traces. And here I see what I've got really with the auto instrumentation approach. I already understand certain things. I see also that I have a problem here in my application, which is kind of interesting. So if I look into this one, maybe make it a little bit bigger, I see I have an endpoint called get to-dos. And I see somehow this is throwing an error. But I don't have any more information. And that is really the thing with auto instrumentation. I go on the edges of my application. So I know now that this endpoint probably is troubling, but probably it's not the endpoint in my app that is causing the trouble. There might be some app internals, but I don't see it from here. Obviously, I could go now into my code base and see what's going on at that particular endpoint, but maybe that's also, maybe that takes too much time. And if we want to have this internal context of our app, actually the auto instrumentation is not helping. So it really just goes to the edges of the application. And yeah, that are just screenshots of it, and an overview. What is good here, if we can use it, we get it out of the box. You saw, right? I had no changes in my code base. I could basically install the packages, but obviously also I have less control of the telemetry data. It basically also gives me everything. I mean, I can install certain packages with a bootstrap command, but still, if I want to have the fast API instrumentation, I really have to take all the endpoints and everything it does for me. And the thing with the error that we just saw, the last one, is I might not have even enough insights into the application context. I stay on the edges. And actually there is the manual instrumentation where that comes in, and that's a code snippet. Outlining it here basically is that you can also import these packages into your code, and you can create a tracer here. So you create a tracer to do tracer, and then already now I hope everyone sees where the error comes from. I mean, it's a simple app. It doesn't do anything super excited, but now I can start in each definition, and including one line of code with a tracer, and use it as a current span. And I have here the get to dos, and I have also another function that gets eventually called, that is a to do with errors. That's basically raising the HTTP exception, and I can use that in the context as well. And I can run and start the application again. I've done this in the morning already, so let's go back to the Jaeger UI. So if I go to the to-do, I see now also here, I should see actually. That is interesting. Let's see. Let's look for it basically for the last hours. Okay, so I see basically here the 3 spans still, and I don't see what I want to see actually. Okay, so maybe we have to run it again. We don't see the let's kill this for a while. Because if I switch the branch where I did the manual instrumentation, fine, let's do push it. So it's there. I even don't know what I changed, something in the script, I assume. But then if I now switch the branch to the manual instrumentation, here we are. I can do the OpenTelemetry. It's all installed, because now I also tell to install the spans that I've created, so they should be here. And maybe something went wrong. And now I give it a service tag or service name. So we have a difference between those two services and we find it easy. And the app is starting. Just cd into the scripts and run the script. Python 3 and then it's traffic.py. Jesus. Okay, that should work. We can, I go back to the presentation slides. We can check that in a minute. It takes some time as well to make it visible. But yeah, what you should have basically seen is, and I make that bigger, in my spans, I'm not only having the 3 that I have before, I have actually this get to do here that I was just defining in the code base. So I have an additional information that goes into the context of my application. So I have further information that this one actually is not having the problems. But if I would now see the one with get to do errors, the get to do -e, I would see that this is actually causing the problem. And then I have a clearly indication which function in my code base is throwing this error. So that's what you see here in the screenshot. So that would give me more details and more indication what is going wrong actually in my application. Also, if we look at durations, it also would give me more information here around durations and what takes long in my application. Okay. And that is only the one thing that we have to do, because we have just touched the topic of traces. Now we also coming to the point where we are interested into metrics. And now you see already there is a lot of things that we have to change in the code. So beside the trace, we also need to import the metrics module or the metrics object, and we create a meter. And from that meter, then actually we can also say, okay, whenever a certain function is called, so I initiate the counter here, but whenever a specific function is called, I want to add a 1 to it. So that's what you see here, and that's basically the function. And I hope this outlines already a little bit that that if we want to debug our application, the auto instrumentation is often not enough, because we need to have the deeper context of what's going on in the application. And now if we consider traces and metrics already, we have a lot of code lines we need to change. And the benefit obviously here is that we have the insights into the application. We have the control of the telemetry data. So we even can now decide really fine graded, also not to instrument all endpoints, but only specific ones. But we have a huge amount of application code changes. If that is only for metrics and traces for one function and only meter, imagine how your code base looks like if you start implementing different meters and different counters and so on. You will have maybe more code that is related to the observability than the code base itself. And then there is a different discussion, I think, that is worth having. I don't say it's necessarily bad, but that is the part where it gets hard to motivate your backend engineers actually to deal with observability, and where often discussions are happening, where the backend engineers ask the SRE and DevOps people, hey, can you instrument my code? And they do the auto instrumentation, which is not enough, but they are also not the ones that want to touch the code base, obviously, because it doesn't really belong into their context. So there is interesting friction, I would say. And I'm also always interested in hearing how other people are solving this, but it's definitely a discussion I've heard multiple times with different solutions. And I think for us, that was really the part, what do we do with that? So we have the edges we can do with auto instrumentation, but we normally do need manual instrumentation to get application context. How can we deal with it in an easy way? And we invented like a year ago almost Autometrics in our company. And Autometrics is an abstraction layer on OpenTelemetry and Prometheus. And it also can give you, based on metrics, a call graph inside your functions. And I think that's quite interesting. So that's actually what we want to track. We also want to track the functions, similar to what I just showed you. Autometrics has the goal to create metrics on your functions based on latency, request, and error rate, and also gives you context about the call graph inside an application based on the labels and the names and metrics. That is the basic architecture that we have. There are more components to it, but I start with this one. So Autometrics provides language libraries for the instrumentation, and we have a look into that later. And the language libraries also provide the instrumentation of your application, but they also allow you to define SLOs, so service level objectives. So you can also go into your application context and say, I have certain functions and they all contribute to a service level objective. For example, I have an error rate that should be, or I have a success rate of 99%. And whenever this error rate gets below, I need my SLO is not fulfilled and I need to get an alert, because obviously we also don't want to get an alert for every error we have in the system, but maybe only if we are under a certain threshold. Autometrics has Prometheus in mind, so you need Prometheus as a storage for your metric data. It's not built by us. It is its own community. It's also a CNCF project, and Prometheus, that's why this arrow is here, normally comes with a pull mode. So you pull the metrics from an endpoint in your application that the language actually, that the library actually provides. And then on top of that, because now we've created your metrics with labels and names, we know how they look like. So you don't have to deal with PromQL. That's a querying language you normally have if you want to analyze your metrics. But we provide some tools here, Grafana, pre-configured Grafana dashboards, if you use them already, that you can use. And we build on top an own tool called the Autometrics Explorer. And that makes it really easy to visualize those metrics for you without the need of writing PromQL queries, and also without the need to have traces, because based on a label called caller, we generate call graphs within the context of your application. Cool. The other part to it is, and that's in our release, is that we have worked on the alerting flow as well. So we connect with the Prometheus Alert Manager, or you can also deploy that independently, this component. And we developed a Slack bot, so the alerts directly can also could be also directly published in Slack. Not focusing on this today, but just the basic about the Autometrics thing. And here, actually, that's the to-do app I was already showing. If you want to follow along, go to the to-do app. And also, if you use this QR code and that link that you see here, that will bring you to a public instance of the Autometrics Explorer. So you can see the data that I'm showing you. You can also play around with it and you can have a look. But it's also very easy to run this locally. Actually, in my GitHub repo, there is an instruction. We have a CLI client that spins up the Explorer, but also Prometheus for you. So maybe check that out and see if you can run it locally if you want to. But I go back to my code base, where still something is running, and just checking if Jaeger is doing what I want Jaeger to do. Let's refresh maybe. If I now see, maybe I just do the last 15 minutes. Oh yeah, cool. Perfect. Also, the new start of the application has led to the thing I just showed you on the slides, right? So we have the 4 spans, the ones that I created. I just wanted to check if it works. It works. Cool. That's always good. So I can keep this running here. It doesn't matter for now. I just like to, oh no, I actually can't. Because I need to go to the code, and I do another git switch. So the code that you see here is actually on the main branch. And now we actually go a little bit into the application, and we go to the endpoints first, because what I've done here in the code base is I use Autometrics here as a library, and also use the objectives here to define SLOs. I have a fast API app, so I define an endpoint where the metrics where the libraries or where Autometrics can generate the metrics to. That's /metrics, and that's also the endpoint where Prometheus can pull from. I come to the SLO later, but what I do now here is in my code is only using the decorator at Autometrics. And we also provide different language libraries. I just do it here in Python, but you can do it with TypeScript, with Rust, with Go. We have community contributions in C# and Java as well. And basically all of them have the simple idea: you put one line of code on top of your, well, I mean, I guess in most languages it's on top of your function or of your method, and that will generate the error rate, the request rate, and the latency. And also we see how that is related to call graphs. And what is the SLO here actually doing? I also can define this observability or observability value in my code base. So I can now say I have a SLO that is tackling all my APIs, and that one actually says I want a success rate of 99%. And now I can give that into the hen, or as a parameter into the decorator for all of the endpoints that are contributing towards that SLO. So I get a good overview. Okay, I have those 3 endpoints and all of them are contributing to that SLO. And whenever I'm below, I want to get actually an alert or a notification. And within my services, I also have instrumented the add Autometrics functions here, or the definitions. So I see here also that my functions with no endpoints are using the Autometrics decorator. And Autometrics provides 2 approaches here. You can also do kind of an auto instrumentation approach where you use the CLI to instrument all the functions in your code base. And that can be a nice start if you don't want to go in manually. But if you want to pick certain things manually, also this is it's a manual approach then still that allows you to go in manually and change the code, but you have the fine-graded approach. And this application, actually, I have it running already. I provided you the link, so I just bring you to Northflank. I used one of the exciting new cloud platforms here, actually, that are out there to show you and just show you what I have here. My example to-do app is running. I have this Prometheus instance, so I'm storing it here. And I have basically the Explorer. All those 3 are somehow, connected. And then, of course, I have the traffic script to also generate some traffics. And if I now go to the front end, you should be able to access this as well. I hope the link works. What I have here, first of all, I have a dashboard with the top functions regarding whatever. I can see also which one gets the most requests. I also can see which one has the most errors. I also can see which one takes longest. Maybe not that interesting now, but if I also check out now the SLOs, that is actually the SLO we defined in the code base. So we have a target of 99%, and we actually see we do have a problem here because this is not met. So I can now check deeper into that one. So that's really the cool thing about the Explorer. It has this whole library idea in mind. And I see here this 3 functions in my code that are contributing to the SLO. And I can see that probably the success rate of the update to do is fine. Get to do seems to have problems, and add to do also seems to be fine. If I scroll down, I also get some nice indications here. Actually, it's the get to do endpoint. We already saw that with the traces, but with the traces, we haven't defined SLOs. I can go onto this one now, the get to do endpoint. And I see here, this is kind of having some problems. And I outlined that with the traces earlier because I wanted to show you, a trace is normally also more expensive to store than a metric, but because we create the labels for you, we can also create a label for the call function, or for every function that is called by a different function, and only based on metrics. And I found that pretty cool. We can also create a call graph. And this call graph is outlining what we've seen earlier, that we have the get to do endpoint. And from the get to do endpoint, we are calling those 2 functions. And there's definitely going more traffic into the get to do with errors than to the get to do successful. And that already gives me the indication that I should investigate into this one here. And the call graph here is finishes. But I mean, in my application context, I could dig down deeper now, even if I want to. I see the graph here, I see the 100%, and it really gives me an indication about the function that is misbehaving. It's actually this one here, the get to do with errors. And that gives me a good indication exactly where I have to go into my code base to debug it. And that was a little bit the motivation behind it to build Autometrics. First of all, not to have traces internally in the app, but use metrics, and also give you quickly insights of your applications. Cool. And that brings me basically to the end. So that's Autometrics. You find the website. We are on GitHub. You find me on the socials. This is news, so we like to get your thoughts on it, your feedback. Yeah, feel free to share it. We have a Discord space. You find us on those channels as well. And yeah, I'm happy to take questions now.
Yeah, we got quite a few because first of all, thanks a lot for sharing, and I believe Neely will share the code link with me later on. Some folks are asking for that in the chat. This is being live streamed on Twitter, LinkedIn, and YouTube. I tried for Twitter for the very first time, and it's working really well. So I'll do it in the future as well. I've compiled some questions we've gotten over the platforms. The first one is, can you see the screen?
Can I see my... No. I go to StreamYard again, right? So should I stop?
Yeah, we can stop sharing.
I stop sharing, yeah.
So I'll just add some of the questions on the screen, and you can answer them in like rapid fire or something.
Where do you add them? Sorry, I missed that.
It's on the screen. The first question is, what are the key challenges you faced when trying to understand your application's performance in production? It's just on the StreamYard screen.
I see only you. Sorry. I see the comments and I see the private chat. Okay. No. Okay, now I see it. Okay, perfect. Sorry. Oh my God, yeah. Technology. No. Sorry. What are the key challenges you faced when trying to understand your application's performance in production? I think mainly one challenge was, even if you instrument the application context, that you still have to write the PromQL queries. So that was the way for us to also say we want to create a tool that also allows you to get these insights without writing PromQL query. That was definitely a challenge that we had for our own applications at Fiberplane, and also some feedback we got from folks. And I think we also were discussing a lot, what are the minimum elements we need to get good insights? And I think there is the 4 signals that's from Google, from the Google SRE space, but I think they make a lot of sense. And we try to implement at least 3 of them. So we have the latency, so the duration, how long something takes, and we have the request rate and the error rate. And I think only having those 3 already really gives you good indications of things that are not working the way they are. And well, the interesting part with Autometrics is that could be something that you put into production as well, and you have those metrics in production. But it also can be interesting when you start developing your applications and you have maybe a certain feeling already that this function might take long. Just bringing in those sprinkles, you already get indications before production, the step before production, maybe for improving your code base, and then go to production. There is a question. Oh, yeah.
On the screen.
Just one question. We have to use annotations always to use the Autometrics. Can't we do something auto-instrument like we did with OpenTelemetry? Good question. So in our CLI tool, we provide a way to auto-instrument, but what it will do is basically it will put the annotation, the decorator for you in that function. So there will be always this extra code snippet in your application code. We say we have the auto instrumentation where it takes everything you have, and then you can not drill it down, but then you can reduce it over the time, or you go in with a manual approach. But yeah, that's what we have now. But if you, happy to also hear feedback around that actually. So how we can make it more useful. when we create, you can Kunal, you can also read it. So it's not a me thing. It's more a dialogue that feels better.
Yeah, Rizwan is asking, when we create a wrapper, for example, Python wrapper in case of Autometrics, so do we convert each and every function, or do we do a REST API call to the actual implementation from the wrapper library? This is one for Nelly.
Yeah, I have to give it when we create an wrapper X Python wrapper in case of. So we don't do a REST call from the wrapper. So the wrapper actually creates the counters for you. So the library, basically you decorate the function, and based on that, the decorator in Python will create the metrics for you and put it to an endpoint. So there's no REST call involved when you use those wrappers. It happens that you have the Prometheus instance next to it, and Prometheus will pull from the endpoint. I hope that answers the question, and I hope I got it the way you wanted to have it explained. If not, feel free to reach out.
Yeah, I'll leave the links to the community in the description below. So even after the session is over, you can get involved with them.
Cool. Yeah, next question is, could you explain why function level metrics are important for improving application observability? Sure. I think, I hope it outlined the two things, that if you do the auto instrumentation with OpenTelemetry, for example, you're on the edge of your function or you're on the edge of your application. And if you want to have context of the application, you always start instrumenting parts of it. I think when we look at functions or methods in Java, the really benefit is that every engineer understands, hopefully, their code base based on the functions, because the functions are the building blocks in our code. So if we use metrics on top of our functions, it really helps us to understand better how the application is performing. And then also on top of that, not only the metrics of each function, but also the possibility to create a call graph within the context of the application is really handy, because you don't need to create the spans for each function, but you can use simply metrics to generate that call graphs. And that has the benefit that storing traces is more expensive, and you normally only do a 20% of traces you store, while with a metric you would do the counter, so you count everything, and it is less expensive to store actually the metric than the trace. I hope that answered it. What are some real use cases where latency, request rate, and error rate metrics have been crucial for optimizing application performance? Well, I think there are a bunch, and I think, for example, if you if you find out that a certain route in your code is erroring, it could give you a good indication that maybe some call that goes to external systems is causing that problem. And the other thing basically with latency, it's the same. If you have, for example, calls to a database in production, and you don't really know how long that takes if you tested it, but if you have more load and whatever, you really can identify those bottlenecks in your production environment and see how it goes. So I think there are multiple things where it can help.
Yeah, couldn't agree more about latency, but also the error rates. And in various fields, I've seen, for example, CDNs, they rely heavily on low latency. But it depends on your use case. And few more questions before we wrap it up, because we're running out of time as well. So just to be cautious of Nelly's time also. But if you have any other questions which we may not be able to answer because of time limit in this session, you can join the Fiveplane community and ask it over there. A few more Autometrics question. Can you provide some insight how Autometrics simplifies the process of setting up function-based metrics in your application code?
Yeah, so basically the idea is you only have that simple decorator or the simple wrapper around your function. I hope I outlined when you use OpenTelemetry, and it uses it under the hood, right? So it's an abstraction layer based on top of it. It should make it easier. So you change a little bit less. You don't have to create or initiate a tracer or a meter. You basically only have this one line of code on each on each function or on each method. And so I think that makes it simpler compared to other manual approaches when we talk about instrumentation. Yeah, I think basically that's it. That's a good one. Are there any specific best practices you recommend for alerting based on application metrics to ensure timely issue detection? That is a broad topic, and I've heard so many people talking about alert fatigue when you have too many alerts being set up. So that is a problem, but it's also very hard to give a general advice because, and probably people hate if I say that, it depends. It depends on your business, on your use case, and where you want to get the alerts from. But maybe be aware of when you define those SLOs, what is the user journey also, and what are the critical points? So when is really something burning for business, or when is it just a nice to have? And because you are now also in the code base, it's nice to understand which functions might be crucial for your business. And then maybe it's also a little bit try it out. If you have too many, I would definitely recommend reducing them because you only want to have the important ones. But if you have none, that's also probably not good. So yeah, play around a little bit with it. And also ask always about the business case and the user journey and the context in there.
Yeah, it's a very good point around prioritizing alerts, because you don't want to lead to like alert fatigue or something when it when you cause alert overload. So focusing on the most critical metrics and alerts when possible. All right, I believe we answered most of the questions. There's still a few left, but I'll leave those to the people to ask it in the channels later on. One last question, which is a good one to wrap up with, is how can attendees get started with implementing observability and function-based metrics in their own applications after this webinar?
Cool. Yeah. I mean, I shared the homepage. We have a GitHub repo. I think our homepage, basically autometrics.dev, is a really good starting point. Depending which language implementation you want to use, you find dedicated guides there for language, not only for the language, but also for the different frameworks of each language. So I just showed Fast API, but there are other language or other frameworks in Python, and you get like good guides on the homepage, and it should really take you on the hand and walk you through the own single steps that you have to do. I also shared the to-do backend repo that I'm using, or that was my example in the webinar. You also find some resources there. There is some files for Python, sorry, not for Python, for Prometheus, and how you can deploy them to a cloud, and so on and so forth. And also another good thing is if you want to have it locally running, you can actually use really, really well the Autometrics CLI that spins up Prometheus and the Explorer for you. And then you only need to take care of the application at that part or at that point.
Amazing. Well, thanks for sharing, Nelly. And yeah, thanks everyone else for joining as well and asking some nice questions. This is being recorded, so you can watch it later on. Had a lot of fun, and hopefully I'll see you at the next conference. And for Autometrics Fiberplane, you can check out the links in the description below. And we'll see you in the next one. Have a great day. Bye.
Yeah. Thanks for inviting me. Bye.